Hi everyone, my name is Emir, and welcome to the Model Context Protocol Basics. In this tutorial, we'll cover various different topics related to MCPs. So, let's get started. First, I'd like to dive into the introduction of MCP. So, when you hear the term MCP, it stands for Model Context Protocol. This is not about how you control systems or cryptography, those that share acronym, but are unrelated here. Instead, MCP in our context is newly introduced open standard that aims to make much easier for AI models like large language models to connect with external resources. A great analogy from Anthropic is one of the AI companies behind actually MCP is that MCP is like a USB-C port for AI. Just as USB-C is a standard plug that fits into many devices and accessories, MCP provides a standardized way for AI agents to interface with many different tools and data sources. In simple terms, MCP defines how an agent can ask for information, actions from other systems. For example, fetch the latest sales data from a database, or access this document from Google Drive in a consistent, secure manner. It's an open protocol, meaning that it's meant for anyone to be implemented and use, promoting interoperability for various AI and tool providers which can support it. And we will dive deeper into how it works, why it's useful, but keep in mind that this is a core idea. MCP is about giving our AI agents a universal connector to hook into software and data ecosystems they need to work with. So you might wonder, can we already connect AI models to tools? We can, but MCP addresses key pain points. One big issue has been that AI models have a limited memory of conversation, which is a context window, and they don't actually have access to fresh external data. Without something like MCP, if you want a model to use as a new data source, say your company's knowledge base, you would have to perform a custom integration, basically write a bunch of code or use a specific library and feed the data into the prompt. This process is often bespoke and doesn't really scale well into many sources. According to Anthropic, even the best models have been constrained by their isolation from data and trapped behind information silos, requiring custom work for each new data source to essentially integrate. MCP matters because it standardizes this connection. Think about how in the early days, if you had different chargers for every device, it was a headache. USB, USB-C solved that by giving a common interface for all. Similarly, MCP means if a tool, for example, a database or an email service, speaks MCP, any AI agent that also speaks this can immediately talk to that tool. It saves developers time. No more reinventing the wheel for each integration. It also leads to a better AI performance as well. So when an AI can pull in the exact data that it needs, say, for example, the latest weather reports or a specific document at query time, its reprocess will be more accurate and context aware. Lastly, MCP emphasizes security and governance as well. Since it's a structured protocol, companies can have a dedicated MCP server that acts as a controlled gateway to their data. Essentially, what it means is that they can monitor what data is requested, and even if it requires authentication or permissions. Overall, MCP matters because it's a big step towards making AI agents truly integrated into real-world systems in a consistent, safe, and efficient way. So, how AI agents use tools today, pre-MCP? Before this tooling came along, developers have been inventing various strategies to enable tools with LLM-based agents. One foundational approach is the ReAct pattern, short for reasoning and acting. In ReAct, AI model is prompted to not just answer directly, but to think step by step and interleave actions with thoughts. For example, an agent trying to answer, who is the president of France? Might reason, I should look this up, and that's the reasoning. And then perform an action, search, president of France, and the result comes back as Emmanuel Macron. Then the agent concludes the answer, and frameworks like LangChain build on this by providing a convenient way to set up tools. In LangChain, you can define a set of tools with metadata, so each tool can have its name, a description of when you use it, and how to call it. And then the large language model is given a prompt that lists these tools and formats to use them. Modern LLMs even support function calling, which LangChain also leverages. The model can output a JSON calling a function, and the framework executes it, then feeds it back into the result of the model. Semantic kernel, which is also developed by Microsoft, introduces the concept of AI skills and planners. It essentially can take a user's request and use a planner algorithm with the help of an LLM to decide which sequence of skill functions to execute to fulfill that request. For instance, if you ask an SKI-based agent which is a semantic kernel-based agent, to schedule a team meeting for next week and email everyone, the planner might choose find a common free time function and then send email function to its skill library. So DSPI is also another approach. It stands for Declarative Structured Python, and it's built by Stanford engineers and researchers. Instead of writing long prompts, you can write Python code where you declare tools and their effects, and the framework ensures the LLM uses them correctly. For example, you might declare a tool for web search and a schema for the expected answer. DSPY will handle orchestrating the LLM to use a tool and produce a valid answer. All these tools, different as they are, address the same core need, giving AI agents the ability to use external tools and data. Each one of them have their pros and cons. LangChain is relatively straightforward, but can be tricky to manage. Prompt tokens. Semantic kernel provides powerful planning, might be complex to fine-tune. DSPY reduces the prompt brittleness by using code, but developers need to learn its abstractions. Understanding these sets up to appreciate how MCP can unify and simplify abstraction of tool integrations. So, agents and external resources, what can they actually access? Let's look at the kinds of external sources and tools that AI agent can use. One big category is knowledge bases and databases. Many agent systems incorporate a vector database that contains embeddings of documents or past dialogues. This allows the agent to do a semantic search for the relevant information when needed, kind of like an agent's long-term memory. For example, an agent might have a tool, Search Docs Query, that looks up to your company's internal wiki for answers. Another category is the web and APIs. Agents often have a browser tool to read web pages or a way to call external APIs. This gives them access to real-time data that wasn't initially in their trained knowledge. For instance, using a weather API to get today's weather in a specific city, or browsing websites news for the latest updates. In fact, in one of the cases with AutoGen, which we discussed in the previous tutorial, an agent could fetch real-time stock data via an API before making a summary. Files and repositories are also accessible with the proper integration. Agent could be allowed to read PDF files or look at a code repository. This is useful for tasks like analyzing large text or debugging code where an agent needs to pull from actual file content. Then we have general tools or functions. This can be anything: a calculator tool to do precise arithmetic, a translator tool to convert text between languages, an email function to automate communications, etc. Each such tool extends what the agent can do beyond just generating a text. For example, if an agent needs to verify a calculation, calling a calculator tool ensures accuracy rather than relying entirely on the LLM's often spotty math. Finally, memory stores deserve mention. While not external in the sense of an independent app, agents sometimes use external storage to keep record of what happens. Some frameworks will write important points to a file or a database so that if the agent needs to recall something from an earlier conversation, it can directly fetch it. And this isn't exactly true learning. The model's weights aren't changing, but it's a way to simulate long-term memory. All these accesses are typically enabled via specific tools or connectors coded in agent's framework. For instance, LangChain's toolkit has SQL database tools, web scraping tools, etc., and others have similar plugins. The key point is, an AI agent is only useful as the tools and the data they can leverage. Providing the right external access can dramatically change an agent's capabilities, which is why exactly standards like MCP are emerging to streamline this access. While the current methods allow agents to use tools, there's still several limitations across this and how it's done. Firstly, the ecosystem is highly fragmented. If I'm using LangChain, I set up tools in one format. If I switch to a different system and want to integrate a new service, I might need to entirely adapt this. There hasn't been one standard for a way to use tools or advertise, hey, I'm here and AI can use me. Each integration is custom and bespoke. This fragmentation is what MCP is trying to solve by standardizing its interface. Another issue is the context window of dependency. So when an agent gets information from a tool, the information is usually has to be put back into the model's prompts or context for the model to use it. LLMs have a limit on how much text they can juggle at once. If an agent pulls a lot of data, say like a content of a long document, it might not fit in the prompts, or more information you feed in, the more dilution and confusion it can happen. This means that agents sometimes still summarize truncate tools' outputs, potentially losing details. Additionally, today's agents don't truly rely and learn from their interactions with tools. For example, if an agent calls an API, gets a response, uses it in that moment, but it doesn't remember the knowledge for future unrelated tasks unless especially programmed to save it, if you made a mistake using a tool, they won't automatically correct the underlying model's approach next time. It's really up to the developers to catch and fix that error. So in that case, reliability is another challenge. The tools can go wrong. Maybe the API changes formats or the internet connection failed. Many agent systems might not be able to handle that. The agent could get gibberish or an error and not have a logic to recover entirely. So unless the developer anticipated this, obviously. So it's not uncommon to see an agent hopelessly confused because, say, it expected a JSON from a tool, but got an error instead. So ensuring a robust error handling often means more custom coding and testing from developers. And lastly, there's security. Right now, if you want to be safe, we often hardcode limitations. For example, limit an agent's browsing to certain domains, or have it ask for certain confirmation before executing something destructive. The human-in-the-loop checkpoints are used in sensitive cases. Without a structured way to enforce permissions, giving an AI agent too much freedom, like file system access, could be very dangerous. So we need better mechanisms within this ecosystem to sandbox or control agent tool use. These limitations highlight why simply giving an agent tool isn't the whole story. We need better infrastructure, similar to which MCP aims to provide, and new ideas to overcome these issues. So now I'd like to discuss a little bit about how MCP actually works in practice. So imagine you have an AI agent that wants to get some data or use a tool. With MCP, the world is set up as servers and clients. An MCP server is like a gateway to a particular data source or service. For example, you might run a MCP server that provides access to your company's internal documents. That server knows how to fetch the documents, but it presents this ability in standardized MCP format. On the other side, your AI agent acts as an MCP client. So when it needs something, it sends requests to the server in the MCP-defined way. Because MCP is an open protocol, the agent doesn't need to know the nitty-gritty of how the server gets the data. Just like your computer doesn't need to know how a USB drive is internally storing files. It just speaks the USB protocol to request the data. MCP defines a universal schema and an interface for various kinds of tools. For instance, an MCP server might advertise, I have a resource called calendar, and it has an action that's called list of events, which returns upcoming events. The agent can see this description when needed, formulate a request like calendar.listEvents for date range X to Y. Key is that all of this is done in a consistent format, likely in JSON or standardized structure. Additionally, the two-way communication means that agent can also send data back. For example, log this note in CRM. The server will do it if allowed, and all interactions can be logged or checked by the server, which adds a layer of safety. An example. Suppose our agent wants to share information between Slack from a database. With MCP, it could connect to Slack MCP server and a database MCP server, and it might send a message to Slack and say, get last 5 messages from project channel and add it to the database MCP. Run query for sales in Q1. Each server knows how to handle its own domain and returns a result in a format the agent can plug in into its own context. Big AI providers are already aligning with MCP. Anthropic's Claude has abilities to work with MCP servers, even provided sampled server things like Google Drive, GitHub, etc. OpenAI's tools function and functioning calling approach are actually conceptually similar. OpenAI agents SDK indicates support for MCP as well. This means that even if you're using those AI models, they can be guided to produce the right kind of MCP requests when appropriate. So overall, MCP works by standardizing the handshake between AI and external tools. One side offers data in null format, the other side requests in that format. So uniformity is what makes it essentially powerful. Now, I'd like to go through a simple example, a case study almost, on with an MCP with a concrete, easy to follow example, essentially. So let's say you ask an AI agent, how many open support tickets do we have today? That's a question that likely requires pulling data from a ticketing systems. Like let's say you're using an internal tool or Zendesk. Without MCP, you would have to specifically prepare the agent and maybe give a tool called get open tickets that you wrote yourself to query the database, and in a prompt, you would hint it to use that tool for such question. This would include and involve manual setup and bespoke solution. If your company then switches a ticketing system, you would have to update the integration, agents programming, and rewrite it entirely. With MCP, assume you have an MCP server for your help desk ticketing system. The server is known to the agent. Maybe it's listed in the agent's available connections. When the question comes, the agent thinks, this sounds like something I can get via, for example, help desk MCP server. And it creates a request in the MCP format, in a JSON or structured call asking, for example, helpdesk.getOpenTickets with parameter today. The beauty is that agent doesn't need to know how getOpenTicket works, just such that function is advertised by the server. The MCP server receives that, runs the actual database query or API call to the ticketing system, then returns a response and says, count 42. The agent receives this and knows that the answer is 42 open tickets. It can then respond to the end user and say, hey, we have 42 open tickets today. The whole interaction was done through a standardized protocol. If tomorrow we build another agent, even using a different AI model or framework, as long as it's MCP compatible, it could also query the help desk server in the same way. We don't need to build the integration again. So the example highlights the benefits. Zero custom prompt engineering for the specific query. The agent dynamically found info with using MCP. Also, everything is structured. The agent didn't misinterpret the number 42 as something else because it came in a defined schema. Overall, this makes such integrations plug and play. MCP reduces the effort and errors in scenarios where AI needs to fetch and update information in other systems. So we talked about a lot of things. We talked about giving agents access to tools and context. But there's another frontier, persistent memory and continuous learning for agents. Right now, most agents, even those with a lot of tooling access, are somewhat like amnesias. Like they don't remember past sessions or improve unless a human developer fine-tunes them. Think of a customer support agent that we just discussed that keeps encountering a tricky question and each day forgets a solution it discovered the day before, which is obviously not ideal. We want agents that learn from experience, just like how people do. One approach is to build a better persistent system or memory to our agents. This could be as simple as logging every question and answer an outcome, and then having an agent review those logs, or as sophisticated as actually uploading the model's parameters new data, even with just external storage, with what we discussed earlier, making agents stateful. But memory isn't enough. So how do they decide what to do with the memory? This is where almost survival-based evolutionary learning comes in. So as spirit agents, we're building a framework that you can work, and later it embraces it. It treats multiple attempts or versions of an agent almost like a population in nature. The agent or multiple agents instances tries strategies. Successful ones are kept, perhaps duplicated, and the failures are discarded or tweaked. Over time, only the fittest strategies survive. So this Darwinian approach means the agent system is self-improving. Concretely, a spirit agent might self-assess after each task. Did I succeed? How well? We have done this previously in a trading competition, and you can actually review the results as well. So if not, maybe it alters its approach, tries a different trading strategy, or spawns a different variant to itself to tackle a problem differently. So this is quite different from the static logic that we see in typical agents today. But overall, MCP gives agents the sense and hence to interact with the real world. Persistent memory gives it the history and context beyond the single sessions, and evolutionary loop gives it the form of self-directed improvements. All of this is geared towards creating agents that aren't just reactive tools, but adaptive entities that can survive in a changing environment, learn new tricks of their own, reduce the need for us to constantly update them. And as we move forward in this program, keep in mind how these pieces fit, and how you will learn to use MCP and current integration techniques as a foundation. And hopefully they will then explore how frameworks like spirit agents can build on top of this with higher level autonomy and persistence. So to conclude, we covered a lot of grounds, from multi-agent orchestration basics to nuts and bolts of integration with MCPs. The key takeaway about Model Context Protocol is that making lives of AI developers essentially easier and agents more powerful by providing a standardized way to connect to AI and to roll of data and actions around it. Instead of one solution, we get universal plug for context. But equally important is to recognize the current limitations and the need to push forward. Beyond just giving agents tools to actually give them able to learn and adapt. That's where the concept of persistent memory and survival-based learning comes in. So hopefully you learned a lot from the tutorial today. Once again, Spirit Agents Framework is one implementation of working towards this vision. And we hope that you will get there with exploring hands-on throughout this program. For now, so make sure you understand the building blocks, how to orchestrate multiple agents for context, how to use tools like MCPs to give your agents the information and tools they need. And in the next sessions, we will explore also the use cases that you can build around this as well, and how we can apply these principles. We encourage you to ask questions. This is a very new cutting edge stuff that most of you are learning with. So feel free to ask questions, and in Discord, engage with the community, and we're more than happy to assist you in your journey during the program here. So thank you for your time.